17. Okay. Now this assignment talks about the concept of Anova. Now there are two types of Anova. There is single Anova and there is double Anova. This chapter is about single Anova. So now the question here is they have 12 individuals that they're suffering of some kind of hostility. So they want to measure their hostility level. So they give them a certain test to measure their hostility first, and then they divided them into 3 groups of 4. And the dividing was done randomly. The first group took method number 1. So this is a method to see if they can reduce their hostility. And this group took method 2 to reduce. And this group took method 3. And they measured their hostility after to see if it's different or the same. I'm gonna write the result of the information in Minitab before and after, or after the test. So you get source, factor, error. That's provided in a Minitab file in that same section where you go and check your assignment. You have degree of freedom 2911. You have SS of 520. Two, 3, 4.8, 754.9. You have MS of 260.08, 26.08. You have the F value here, and that's 9.97. As your F value, and next to it you have the P value, and that's 0.005. You're also given the Tukey analysis, 2 versus 1, 3 versus 1, 3 versus 2. Numbers are -18 to 0.34. Second one is -26, -5, and the last one is -16 with 3.84. You're also given the graphs. This is the residual graph. You're also given the probability graph. And you're also given the histogram. You'll see this in your Minitab anyways. So now the first question. based on the individual plot, are there differences? There is also a plot given in Minitab by itself. It's called the individual plot, and it said method 1, method 2, method 3, and there was like dots like this, and there was a line going, connecting this to this trait, and then leaning up a little bit and connecting this. This point represents the mean for method 3. This one is the mean for method 2. And this one is the mean for method 3. Now, the plot, the averages, if you look, they're not at the same level. They all are different level. So, basically what you see here, looking at this graph, you say the averages seem to be at different levels. Therefore, their difference. We see difference here because they're not at the same level. Like, for example, if you had a mean here and a mean here and say another mean here, you would say they're pretty much at the same level. Then you say, well, yeah, that looks like they're not, but they're not at the same level, then there are different. Okay. Question 2 was to discuss the assumptions. The first one is the independence assumption. And this condition is met. And you know this assumption, you've seen it so many times. Selection must be done randomly. And they mention in the question that when they had the 12 individuals and they divided them into 3 groups, they've done this randomly. So the assigning of the 4 individuals in each group was done randomly. And then the second assumption is equal variances. Here, they want you to divide this into 3 sections. Similar, spread, condition, does the plot thicken, condition, and the normality, or also called nearly normal condition. Let's look at the similar spread. Remember that graph that I drew like 2 minutes ago for method 1, method 2, method 3, and the means were connected? When you look at the similar spread, you need to look at the lengths of this. The lengths of the dots here, and the lengths of the dots here and here. That's called the spread, the length of each dot. Does it look the same? If you look at the graph, yeah, they look the same. So you say dot plot shows that spread points similar, also called vertical distance. So the vertical distance is compatible. You can compare the vertical distance to each other. They're compatible. They look the same. We're good. Then you talk about the plot second. Now, this graph here, top right corner, is called residual versus fitted value. And if I just maximize it, again, you'll see it in the Minitab provided. There was like a line here, then this for method 1, method 2, method, something like that. Now looking at this, there is again no change in spread. So this, if there is no change in spread, it's the same spread the same way, so the condition is met. So you say again, condition met, does not appear to be a change in spread. And then you look at the nearly or normality or nearly normal. Now if you look at the histogram is not the best histogram. It's not symmetric. It was like something like this and 2 or 3 like this. So there's gaps, and it's multi-model. It's not the perfect. It's not a good. So there is no symmetry. However, in this case, you look at this graph. And you'll see there are points below and under, and they're all within a certain range. So none of these points are up there or down there. They're all within the same concentration pretty much. So in this case, and also you can argue that, well, although there are gaps and multi-model, but if I divide this into, if I put a line in the middle, it's kind of symmetrical. So you can say, instead of saying no symmetry, you say we have gaps and it's multi-model. However, we can say it's kind of symmetrical. So it's kind of symmetrical. And the points land within the same confidence bands, we say. So you say that. So change my answer. I said no symmetry. Change it. Histogram shows gaps, multi-model. However, the graph still shows symmetry, and the probability plot shows that points are within the same confidence band. So in this case, you say condition is met. It's also recommended to talk about the outliers or outlier condition. Again, there are no obvious outliers, so condition is met. Again, there are, in this graph, for example, you don't see like all the points, but you don't see like a point all the way up. They're all within certain limit. There are no obvious outliers. Okay, so this is to discuss the conditions and assumptions. So conditions are all met. State the hypothesis. So the next one is to state the hypothesis and define parameter. For single ANOVA, we say mu1 equals mu2 equals mu3, or at least one of the mu's different. And they want you to define mu1. B, population mean of, and what's this mean? The mean in the question is for hostility level or hostility score. And since this is M1 for all individuals with hostility treated by method 1. And if you're asked to define parameter 2, would be population mean hostility level for all individuals with hostility treated by method 2. In the next test, they're asking you what's the formula for F and how was it calculated. But in fact, I want to talk about this because that's not how the question in the exam will be asked. Now, if they want the F test, the formula is you take MS factor over MS error. You take this number, MS factor 260.08, and MS error, which is 26.08. You divide them, and that will give you the 997. However, I want to show you how is the question going to be asked in the exam. They will give you the table with fill in the blank. So they give you source, you have factor, you have error, and you have total. Degree of freedom, they might leave this all empty for you to figure out. So let me just use a different marker. So the degree of freedom here, they might leave it for you. Also the one here, and also the one here. For SS, they'll give you two of them. So maybe the first one will be given and the last one. and they will leave this one for you to figure out. Then you have MS. You don't need this section anymore. For MS, again, they might give you one of them. And ask for the second one. And finally, the F value is for you to figure out. Okay, so we will see if we can create the same table if we're just given this. Now, what we need to know is how to do the degree of freedom. Remember from the question, we had 3 groups and 4 in each group. So the total number of people is 12. Groups in Anova, also called treatment or factors. So here, the degree freedom for the factor would be number of groups minus 1. There are 3 groups minus 1, 2, and that's why this number was 2. For this one, it's the big sample minus number of groups. Altogether, the big sample is 12, and there are number of groups 3, then this number is 9, and that's why this number is 9. The total, you just add these two. And that's why we have 2, 9, 11. So for the factor, number of groups minus 1, for the error, the big sample minus groups, and here you just add them. For the SS's, these two, the first two, the factor and the error, both of them must add to the total. So this plus this must add to this. If you're missing this one, you just minus these two numbers. So you take the 754.9 minus 520, and if you do this, that will give you 2348. So if this number was given, and this number was given, and this number not given, to get it, you minus these two. And if these two given, and that's this number not, you add them, you get this. So basically, first two must add to the third. Now you do the MS. First one is done. MS is basically SS divide degree of freedom. So for example, this 260 was the SS 520 over 2. So you go this over this gives you this. So same here. This over 9 gives you this number. So 234.8 over 9 gives you this, and that's 2608. And the F value, like we did here, you take MS factor over MS error. You take the 260 over the 2608, and that gives you 997. P-value will be given to you, so don't worry about it. So that's how you fill in the blank if you're asked, and I think that's how the question in the final exam will be, is they give you the table, and they want you to fill in the blank to figure out everything else. Okay. Talk about the strength. Now, looking at this p-value, p-value is 0.005. And this is between 0.001 and 1%. That would be, I think, in strength level number 4. And in this case, we have good evidence or strong evidence to support HA. And then they want you to talk about the conclusion of this. Remember in the hypothesis, we had mu1, mu2, mu3. And here we have at least one of the mu's not, at least one of the mu's is different. According to the strengths, we're supporting HA. So we know that at least one of those three methods different. So we say, since assumptions hold, we have strong evidence to show HA. But you have to talk about HA in words to show that at least one of the population means of hostility score is different for all individuals who were treated by method 1 and all individuals treated by method 2 and all individuals treated for method 3. Assumptions hold. We have strong evidence to show at least one of the population means of hostility score is different for all individuals by method 1, 2, and 3. So one of them or one of these methods different. But the question is, we know that one of them is different. So, between method 1, 2, and 3, one of them is different. But which one? So the question is, which one is the different group? And that's why we have this Tukey. This Tukey analysis is designed to tell us which group is different. In your assignment, they wanted you first to explain 2 key for 1 versus 2, which is this one. So explain or interpret this in English first, and then we'll talk about whether they're different or not. So to talk about this, we say, since assumptions hold, we are 95% confident that the population mean hostility score is different delta score between all individuals treated by method 1 and all individuals treated by method 2 is between, and you put the two numbers. And if you see, 0 is not within, and we talked about this earlier, and 0 is within, sorry, and since 0 is within confidence interval, the groups are not different. So if you remember when we talked about negative, negative, positive, positive, they're different since 0 is not within. Negative, positive, they're not different since 0 is within. So this is to talk about it. But now, how can you determine which group is different? Now, if you look at the 2 key, 2 versus 1, 3 versus 1, 3 versus 2. Negative 1984, 26, negative 591. Okay. If we take this one, for example, 3 versus 1, 2 key. Both numbers are negative. 0 is not within confidence interval. Therefore, the two methods three and 1 are different. So if you take this one, they're both negative, so obviously right away you can conclude that they're different. But here you have negative, positive. That means they're not different. This one, negative, positive, again, not different. But if you look at these two, this is negative, positive, but the negative is way more than the positive. This is just a little bit above 0. So it could have easily been negative. This one doesn't show anything. So if I take 2 versus 1, first number is negative, but the second number is a little over 0. Meaning that these groups are the same but almost different. These methods are not different since 0 is within. However, since the upper end is, continue here, is slightly over 0, the methods are almost different. So what does that mean in conclusion? Do we know the different group? Okay, so we look at this negative, negative, so we say they're different. Here, negative, positive, not different. Here, negative, positive, not different, but we say almost different. Now, between the different and the almost different, which group is the common group? 1. So 1 versus 2 shows almost difference, 1 versus t difference. So therefore, your conclusion is, from the 2-key analysis, we can conclude that method 1 is the different group. Good. This is again the section for single Anova. 2 more chapters, I believe, left. When I was writing or typing the answers, I of course didn't submit, but I think I lost the connection at some point. So when you review the videos, so I want you to review the videos right away. If I provided all the answers, I think I lost the connection when it was towards the end, so the last 2 maybe. So make sure that if you see no answers to type, 1 was for explaining what the 2-key means, and 1 was explaining. Both answers you'll see in the video. So look at it. And again, the only 2 chapters left are the double regression or multiple regression, which is the chapter before this. You did single regression, so you still have multiple regression. And here you have Anova, and then 1 Anova left, which is multiple Anova or double Anova. And that would be it. So the next one, we'll do a session as well to explain what it means. If you have questions, you let me know, and we certainly can go over it. Good luck.